In the last section that we'll be covering for the summer assignment, we're going to focus on quadratic models. Just like linear models, we will be basically applying quadratic curves to word problems or real-life situations. I have two situations I would like to go over. The first situation, we have a bunch of TVs that at $500 they can sell 20 in a week, and at $450 we can sell 24 in a week. And the goal is to basically write a quadratic equation. So part A, write a model for the revenue. Revenue means the money brought in. So if we want to find the amount of money brought in using this model, we need to find how much money we're selling them for times the number. So in this problem, if we sell 500, if the price is 500, we're going to sell 20. So if we have 500, we're going to sell 20. If we sell 24 in a week, we're going to sell $450. So basically, for every $50 discount in the price, we're going to sell 4 more. So therefore, it's 500 minus 50 times X. So for example, if we have one discount of $50, two discounts of $50, three discounts of $50, that's how much it's going to go down. So for over here, the number we're going to sell is 20 plus 4 times X. So we're going to increase, for every increment of $50 discount, we're going to increase by 4 TVs. So this should give us the number of TVs, this should give us the price. So let's check it out. If we have one increment of $50 decrease, this price would be $450, this number would be 24. If we have 2, this would be 400, now we'll sell 28. So this model does work for us. And that's going to equal R of X, the revenue of X. So the next part, it says, find the price that gives the max revenue. So let's find the max revenue. We know how to find the vertex of a quadratic, negative b over 2a, but that only works if we write it in standard form. So let's real quickly FOIL this out. I have a calculator so you can see my calculations. So we have 500 times 20. Just to make sure we're correct here, it's 10,000. Plus 2,000. X minus 50 times 20. So minus 1,000. Just because it's early in the morning, just want to make sure. 50 times 20, 1,000, and 500 times 4, 2,000 looks good. And lastly, minus 50 times 4 should be 200, so negative 200. So now, I'm just going to reorganize it real quick, just so I can see it better. So it's negative 200x squared plus 1,000x plus 10,000. So now let's find the max. I said the max, find the price that will give the max revenue. So X equals negative B all over, so negative 1,000 all over 2a. So that will be negative 400. So 1,000 divided by 400 would equal 2.5. So 2.5 x increments of 50. So obviously it's not an exact figure, but it doesn't need to be. This was saying every $50 increment. It could be less than $50. So if I type in 2.5 in for the x, I get 500 minus 50 times 2.5 to get $375. So the price should be $375. I didn't ask you for the number of TVs that it would sell, I just asked you for the price, so all I did was plugged it into this part to figure out the price. The second question I have is a physics question. Let's let h of t equal negative 4.9 t squared plus v sub naught t plus h sub naught. V sub naught here is the initial velocity, and h sub 0 is the initial height. And obviously negative 4.9 is 1/2 the gravity constant from physics class. So write the model as part A. When you throw a rock at an initial velocity of 20 meters per second and a height of 40. So let's just plug those numbers in. H of t is equal to negative 4.9 t squared plus 20t plus 40. When will it hit the ground? Well, if you map out this graph, the graph will look like an upside down parabola, something like this. So here's what we're looking at. We're looking at when the height will be 0. So when h of t is equal to 0. We could try factoring this and all that, but I really highly doubt that's going to work. I'm going to real quickly just plug this into the quadratic formula. So you have negative 20 plus or minus the square root of b squared minus 4 times a times c all over 2a. So when I plug this in, sorry for my calculator not being the best, better. So 20 squared minus 4 times negative 4.9 times 40. This will give me the discriminant of 1,184. I'm going to square root that to get 34.4. So I have negative 20 plus 34.4 divided by negative 9.8. So our first value is negative 1.46. And the other value would be negative 20 minus 34.4. Divide that by negative 9.8 to give us 5.5. So obviously this does not play a part in this situation because time equals 0. The initial height was at this point here. So this would be talking about in the past, theoretically. But 5.5 would be the answer of when it hits the ground after you throw it. The max height. The max height, again, is just a vertex. So x equals negative b, negative 20, over 2a. You can see on the graph, this should be a positive number, and you can see by the formula that it is working out to be positive. So negative 20 divided by negative 9.8 to get 2.04. I asked you for the max height, so we do have to plug this back in for h of t. So the height at 2.04 is equal to negative 4.9 times 2.04 squared plus 20 times 2.04 plus 40. So the max height is 60.4. And that wraps things up for this summer assignment. This should prepare you for the last section of the summer assignment, and you should be able to complete it. Again, we will go over all questions on the first day and a half of school, and then we will continue with Chapter 1, where I will cover the more complicated problems only.